Here you select the different sheets and poles, and then you hit nest. What this is doing is it's taking into account the predictions that Roboflow has spit out from our camera, and then it's nesting the actual parts onto the sheet, and it's creating the G code.
Hey everybody, welcome to this week's Roboflow Live. I'm Joseph, I'm co-founder, CEO at Roboflow. Thrilled to be joined by Kenneth Cassel, founder, CEO at RMFG. We're going to be able to do a factory tour today of everything that RMFG builds and creates for their customers. And actually the origins of this came because I saw on Twitter an awesome custom app that Kenneth built that uses vision to improve the efficiency and efficacy of some of the metal parts production that they do. So we'll do a deep dive into that as well. So first things first, I'll introduce briefly myself and some of the things we do at Roboflow. Then Kenneth, I'll kick it to you and we'll hear all things RMFG. So as noted, I'm Joseph at Roboflow. We make it easy for folks to create and deploy visual AI to production. Everything from assembling data sets, training models, deploying them, running them at the edge. A little over 1 million developers build with Roboflow, including half the Fortune 100 and awesome upstarts and startups all across the globe. We're always continuously inspired by the things that people build and create when you put computer vision in their hands. And today is a great example of that. Kenneth, welcome.
Hey, Joseph. Thanks for having me. Hey, guys, I'm Kenneth. I'm the founder of RMFG. Basically, we make metal parts for customers. So we are a vertically integrated metal fabricator. We build a bunch of custom automation to make the production of parts faster. We do stuff with vision models like what we're going to show you. And basically we mostly serve as hardware startups. We do a little bit of aerospace. So we do sheet and tube metal. And recently we started doing welded parts and assemblies for customers. That's been taking off. So really the idea of us is like, can we be a next gen metal fabricator, a place where you can get parts like incredibly fast, full assemblies fast. And over time, we'll kind of continue like moving up the value chain and turn more into a contract manufacturer. And the vision is like, can we just like be like, this ultra reliable, super fast source for custom components for people that are building things.
Before we dive into some of the vision stuff, someone starting a startup doesn't have to think about like starting a factory. Can you give us some context into where the origins of RMFG come from?
Yeah. So immediately before this, we were basically working on this like robotics idea. And so we had saw like a bunch of these like really interesting papers coming out. There's like the SACAN paper and like some of these other kind of like papers that basically showed like you could do more interesting stuff with robotics, right? So like as like vision models were getting better, as LLMs were getting better, you could kind of like chain these together to kind of do like really interesting, new kind of tasks that were previously like either impossible or incredibly hard to do, right? And I think that's only accelerated. And so originally we were just like strapping cameras to like off-the-shelf robot arms and like building like pick and place maneuvers and making it really easy to do kind of like new procedures with these robotic arms with the goal to like rent them to manufacturers. Ultimately, it just felt like it was the wrong business model. Maybe for me as a founder, like it felt like too abstracted away. It was like an uphill battle trying to convince a lot of these manufacturers to kind of like, take a bet on some kind of new automation. And so we ended up like kind of slightly thinking differently about the problem. Like if we think like, vision models are going to get better, robotic capabilities and dexterity is going to get better. Like what position can we put ourselves in to like kind of like take best advantage of that? And so we decided to become a manufacturer. So we started talking to a ton of engineers, and ultimately what we found out is like, there's a lot of places you can get kind of quick turn, like individual components. But once you need something beyond that, like an assembly, like things welded together, et cetera, like there's not really a ton of great options, especially if you need parts fast, right? And so we decided to jump in. So we bought like a laser cutter. It's like a 30-foot long machine, and we leased a warehouse, and we started building things, and, learning a ton. And we didn't really have any kind of manufacturing background either, so it was like a huge kind of learning curve, like figuring out like what customers wanted, like what things were important to them. We messed up a ton of parts and made it right by our customers, but we're roughly a year in now, and things are going pretty well. Like we get things right mostly the first time now. And we kind of had this ethos of like, if there is like an issue or a problem, the best way to go about it is like, hey, how do we solve this like permanently? How do we make it so like the job of the operator is so easy. It's impossible to make, this category of mistakes and stuff. And so I think like, some of this vision stuff that we're doing is like a manifestation of that, right? It's like a way to kind of like make the job of the person making the parts easier, and also kind of like just make it impossible to make certain types of mistakes.
Can you tell us a bit about like the customers who are coming to you for custom machined parts?
Yeah, for sure. I mean, most of them are like fast moving startups, right? So we have a ton of like venture backed startups that are ordering parts. So, these are people like Pipedream, they're building underground delivery robots. Actually, Cannon's swinging by the shop today. He's one of the co-founders. They're based in Austin. We have guys building drones. We have customers like Rainmaker who are, doing cloud seeding programs. We have some really big aerospace companies that we can't tell you their names, but you would know them. So it's kind of, and then we also have like, kind of like people just building random car parts or random kind of products in their garage that are like, trying to get off the ground. And, maybe they don't have the manufacturing capabilities, but they have like a product idea and they're, doing the design, and then they just want someone to make it and ship off the parts to them. So pretty wide kind of variety of customers, but I would say our bread and butter is kind of venture-backed hardware startups are the people who use us the most. And I think a large part of that is just from the aspect of like speed, right? So a lot of them are really kind of like constrained on, they want to find a vendor who can get them parts extremely quickly, and they're like willing to pay a premium to do it. And so that's who we primarily service.
The parts that you're producing, is it someone is they come to you and they already have the CAD of the part they want to make, and it might be like a first prototype of something, and they therefore emphasize speed above all else and like kind of being bespoke? Or do you also have customers that are doing like large scale up stuff that are operating at higher scales that are like, hey, this is the same part, we need a bunch of this? Like, do you find specialization and amongst standardization versus custom and bespoke?
Yeah, I think we have like a bifurcation of customers where like by order counts, it's mostly people ordering between like 1 and 100 parts at a time, right? And these might be like one unique kind of design, or it might be 10 designs, or it might be 20 designs. And they're ordering, hundreds or thousands of dollars worth of parts. And then on the other end of the spectrum, we have customers who we've built relationships with that are ordering on the order of like tens of thousands, or
Amazing.
in one case, like 6 figures number of parts, right? And so I think there's this kind of like behavior where like the customer has a really great experience on like the low order volume thing, then they're kind of like, hey, like, can you also do this other thing for us? And for us, it kind of helps out right now at this stage to kind of have both, because we can kind of even out kind of the production, right? So like we can, as the small orders come in, we can, rate them and ship them off to customers, and then still have at least like some idea of what the order volumes can be over the next month or two, so that we can, hire people, kind of build out capacity and that kind of thing. So yeah, it's cool serving both. And I feel like the technology, if we're servicing the small orders, actually helps us a little bit on the big orders too. Cause like, we try to do everything extremely fast. We try to like remove all the kind of like paperwork overhead, try to put everything to software as we can. So like we could do things like if we have a really big order, kind of like batch and schedule it out where like, okay, we need to make, 50,000 of these parts over the next like month. We could just like insert it into our system where, it's, a few thousand here, a few thousand there, et cetera, kind of schedule it all out. Yeah.
One of the things that you do a great job of is sharing your story on Twitter of like the things that you're building, or X, as you get a new customer, or as you share or create a new part. Recently, for example, like last week, you were like, "Yeah, I just need to blow off steam and get out of the IDE and jump on the forklift." What were you blowing off steam last week when you jumped on the forklift to do?
I mean, I think often the blowing off steam is like, hey, there's some part of the process that's annoying that we haven't automated yet, and like I am the bottleneck like for the whole company. And so like right now, that's for these like weldment and assembly kind of purchase orders, right? So like we have like an instant quote system for laser cut and bend parts, and even for some small subset of welded parts. But a lot of our volume and revenue comes from these kind of like more traditional kind of flows between customers where they're emailing, it's like a procurement guy, they're emailing a bunch of files and parts over, and then we have to figure out, hey, like, can we make this with our like, you know, our standard set of like tolerances and tooling, et cetera, and can I price it all out and like ship it to them, and so like, and give them a quote like as fast as possible. And so right now it's not the best, but like we're building some internal tools to like make that process basically as easy as doing like the instant quote stuff. So we're building some kind of like agents that are, you know, parsing the engineering documents and figuring out, you know, what are the specifications, like what material it is, does it have like hardware insertions, are there weld call outs, putting all that into like a format that our internal software is built with, right? And the idea is like, it's really hard to scale up like high mix manufacturing if you're looking at drawings like all the time. And so the way a lot of people get around it today is like, oh, hey, like you can only order it through kind of like an online system and you configure it or whatever. But there's a lot of buyers that we found that they're just not going to do that, right? Like they're maybe not an engineer, maybe they're a procurement kind of specialist or whatever. And their job is basically being an email and sending out quotes to many different suppliers. And so we want a way to service them, but like still get the benefit of like, how do we not spend man hours like looking through drawings and making sure we can actually, you know, make these parts, et cetera. And so we're building technology there. But yeah, I think that was like, I was working on a bunch of quotes and like felt like I wasn't making progress because like, you know, I wasn't building technology. I was like, you know, just sending quotes out and like manually doing it. But part of it's like learning, right? It's like, okay, you know, if I get really good at this kind of thing, like I could build the technology to make it faster or whatever. And so it was like great to like get off the inbox and just go out into the shop and, you know, kind of help out. And so like this video is actually like everyone had went home for the day. I went home, ate dinner with my family, put the kids to bed, came up back to the shop, and then knocked out a bunch of stuff that would make the next day of production go faster.
That's great. That's great. You touched on this a bit earlier. I want to dive into internal software you're building and using vision to do it. So you shared this TikTok, or actually it was an Instagram reel of one of the apps that you've built that is internal software. And we've gone ahead and kind of broken it up into the component parts that you see on the screen here. Could you tell us a bit about what the internal app that you built does and how it leverages vision and what impact that has on your production process?
Yeah, for sure. So basically, most of our parts start as flat, raw sheets of material, and then you cut out the parts, and then there's secondary processes that happen. So you can see in the image, this is kind of like the laser bed with a remnant sheet cut out on top of it. So this is basically like we had cut a previous customer's order out of this sheet, but now we have a bunch of sheet left over. And so the way a lot of traditional shops get around this is like, either they'll say like, hey, you buy the whole sheet of material, right? Like if you're going to buy a part, like you actually need to buy the whole sheet of material. Then we don't really have to deal with like, oh, you know, basically like what happens to the remnant sheet after, what happens to scrap? Like, are we going to make money on it, et cetera? It's really labor intensive to like, if there is a remnant sheet, to nest the parts out onto the sheet. And I'm trying to figure out like a better way to convey like how annoying it is, because I think like if you just look at it and you've never operated a laser machine, you might think that you could just like load up the material into the laser and then just kind of like manually put the parts onto the sheet. But the laser itself has like no idea where the raw material is on the sheet. And so you're basically presented with a screen and you can kind of move around the parts on the interface on the laser with no reference for where the actual material is on the bed. And so it makes using remnant sheets really difficult. For this example, like if you had an operator have to manually nest these parts, it might take them 10, 20 minutes to do. But using the vision software that we built, it's basically, 30 seconds. And so I think there's like a huge amount of benefit here. One is like you can use more of the material. That's like the obvious benefit, right? Like, okay, you have remnant sheet. I want to cut out other parts out of the sheet, but I want it to make quickly. But also going back to like the idea of like making certain mistakes impossible to make. This is like a great example of this, because we've written our own nesting software. So we create the G code that gets sent to the laser directly. And so we can do things like make sure that we have all the right compensation parameters, make sure we have the right amount of lead-ins, which is like where the laser is going to start. So it doesn't actually cut the material itself, but it starts a little bit out of the perimeter. So you get a clean cut. And there's like a bunch of other steps that an operator will take. A traditional kind of flow, like there might be 20 distinct steps that you have to make to correctly like load up a sheet, add all the material, get the right count, etc. But by moving it all into software, we kind of delete most of those steps, right? And then after the sheet's cut out, we also have the benefit of, since we're already built this model to kind of like outline the sheet and the holes, we can use that as an inventory tracking system as well. That has like real-time kind of true tracking, right? So the real world is messy. Let's say you want to cut out 10 parts. Sometimes you end up cutting out 12 parts. It's hard to like get that data into kind of like your own internal systems. So you get a real idea of the cost of making the parts. But if you have everything in software and you can scan and see, hey, like, we actually ended up running this program 2 times and we cut out 2 extra pieces and here's the amount of material left and here's the percentage that we use. All of a sudden you have like a much finer grained insight into the real cost of production. Also, the other side is like not every operator is as equally skilled, right? So like if you're going to have an operator manually nest onto remnant sheets and then a separate operator do it, they might do it completely differently. You wouldn't be able to kind of like, it would be really hard to kind of like incrementally get better at using the material. But like since it's in software, we can kind of like create new nesting strategies, back test it on previous examples, and just kind of like there could be like this measured continual improvement. Metal fabrication is not a super high margin business at scale, but I think it could be. And I think part of it is just like using technology to making sure that like you're using as much of the raw material as possible. You're tracking everything that makes sense that, goes into the actual cost of the parts. And so, yeah, I mean, maybe a long-winded answer, but this has been kind of like a game changer. The operators love it. It makes their job a lot easier and makes it easier for us to make more money.
Really comprehensive. So you have a piece of sheet metal, and previously it wasn't known what amounts of that sheet metal were going to be used across a series of parts. In a world of vision, you're able to get clarity of how much of that metal has already been used, how much can be reused, and then also where you want to start production of subsequent parts, because you know how much you have remaining and you can tell the fabrication where on the sheet to start. And I think, as you said, that sort of makes benefits of keeps your costs more optimized, because you can either pass those savings on to customers of instead of having to pay for scrap, you can just produce higher quality parts with less material. And 2, the standardization that you mentioned. So basically, like every shift can be your best shift is something that we often hear in a world of vision.
Yeah. And so like scheduling is like really hard for like high mix manufacturing, right? And so like if you're using humans for all the processes, it's really hard to know like, okay, is like operator A going to take 20 minutes to nest this or 30 minutes or whatever. But the more you can get into software, like I think we can get really, really close to saying like, your part is probably going to be made in this like 5-minute window, right? And so like that's kind of like the goal that we want to get to, is like your part's going to be cut out like right now. That's kind of like what we're predicting. And yeah, it's just it feels like we're super early in this kind of like, adding more and more of the real world stuff to software, but it's super powerful. Like really excited about this.
So describe the like really almost like you're describing it to an LLM, if you will, step by step what happens here. So like a piece of metal comes into the fabrication machine. The camera's positioned up above.
Mm-hmm.
Next. What happens from start to completion of this process?
Could I share my screen? I could just.
That'd be awesome.
Okay. Let's see. All right, cool. So I have this kind of redacted version of our production software, and you can see a bunch of different orders that have come in. So this is like our quick turn order side. And I could just go to kind of like the latest order, right? So if I go here, I can see what the parts our customer ordered. what material it's made out of, and the quantity. If I want to go then cut these out, there's basically a button I go to that's like the configurator for the laser machine. So right now it's capturing the image from the laser bed, and you can see these are the materials that are currently on the laser bed. So, and there we go. There we went ahead and run the model. We need to train it better. Like, I think we only did this with like 60 or something examples. So I think over time it's going to get closer and closer. But basically what this does is it finds the outline of the sheet, and then it finds any holes in the sheet. From here, let's say I want to cut out a couple different parts. I add them to the queue, and let's see two. Sorry. Oh, okay. 1 second. All right, so let's do 2 parts. And that converting thing right there is also some of our internal software. So maybe a little extra detail for people interested in fabrication, but if a customer orders a part that's bent, they might design it in a way that's really close to what we can actually make, but not exactly. And it depends on the tooling that we have for a bending machine. And so we have some software that automatically kind of like adjusts the file to the right flat pattern so that we create the part to the right final dimension. So that's some stuff that runs in the background. From here, you select the different sheets and holes, and then you hit nest. And what this is doing is it's taking into account basically the predictions that Roboflow has spit out from our camera, and then it's nesting the actual parts onto the sheet, and it's creating the G code.
Oh, wow.
So you can see now, we have these couple parts that are nested. The other cool thing about this too is that it's really hard to explain like how much faster this makes the operator job. But if they were using this exact example, it would probably take them at least 10, 20 minutes to set this all up. But we've done it in about, 30 seconds. And so, over time, we'll keep making this better and better. But yeah, send G-code to laser. What this does is it sends the program directly to the laser. And then the operator will just, basically import the file, send the laser to the bottom left corner of the cutting bed, and then press go, and it'll cut out the parts. And yeah, so now we know like we have exactly the right amount of parts that we wanted. And there's like no opportunity for the operator to like, before they would have to import each individual file, and then they would have to go look up inside of the software. Oh, how many of these do I need? Okay, let me go and put 2 or 3 in there. And now it's like exactly the right amount. And then if let's say you wanted to make, some additional for whatever reason, you can like, just go over here, and you can nest more parts, and it should work fairly quickly. So kind of the next step after this that we're going to build is inventorying the sheets post-cutting.
I was going to ask you to keep track. Yeah.
Yeah. So we're going to do that next. We do keep track of the previous nests that we've done too. I can show you guys that.
So by inventory, you're saying after you cut a piece, you then want to keep track of the amount of sheet that you have remaining for subsequent jobs that you'd want to run.
Yeah, exactly. Oh, just let it 1 second. And then we have this page where we can see all the previous nesting results and a bunch of details about them. And the idea is like, every time we nest something, we can use Roboflow's API to kind of add more images to the data set until we get, a really good kind of, here's a bunch of different ones that we've done. So trying to see which ones that I have hard to do, so I can show you an example. Yeah, like here's a great example. So this would take literally so long to do if you were going to manually nest it, but
wow,
it just took exactly how long that we showed. And so you can see it's using so much of the material. And so like at a regular shop, it's maybe a little hard to see the outline of the raw material, but there's two big cutouts right here. A regular shop would probably just like cut it in half and just leave like a rectangle piece. But
Right.
look at all these parts that we made. And for us, like anytime we throw away like material that hasn't been made into a part, it's like really painful because like the material is worth way more if you make it into a custom part. And it just feels like throwing $100 bills like in the garbage. And so the more we can actually use the material, the better it is for us. But yeah, you can see this is kind of like the
I see the holes.
situation. Yeah. So anyway, yeah, that's the overview. I can walk you guys out into the shop really quickly. It's kind of loud out there if you want to see the actual laser.
I was gonna sort of put you on the spot to do that. That'd be awesome.
Okay, cool. Let's see. I might put myself on mute. Stuff on mute.
Well, Kenneth does this. If you have Q&A, please toss them in the chat because I'll start to triage questions for Kenneth as we get to do the live factory walk here. All right. And I don't know if folks caught this, but for context, Kenneth's factory is in Texas. Here's the fabrication machine. US of A. Here's the team making parts. Scrap. No longer scrap. An active shop floor. Pallets and pallets of both produced parts, and it looks like soon to be produced parts.
Yeah, we're pretty space constrained right now. We're about to move into like triple the floor space, but it's really out there because really loud out there. They were grinding down some weldments that we were doing. But yeah, you could see like, basically you end up with a ton of sheets that have parts cut out on them, and it's a big problem, and it makes it way faster to actually cut the parts out. And so, yeah, we basically, we basically deployed like the very baby version of this vision software, but I think it's going to do a lot more for us, right? So we'll be able to kind of like, track material usage and see how many parts we actually cut out and like track defects, et cetera. And there's like a lot of opportunities in like other parts of the shop that we can use vision models too that we're super excited about.
Could you tell us a bit about that? I was going to ask you for like how you identify, this smells like a good vision problem, if you will.
Yeah. Another one that's super common is like people will order parts from us that are bent, right? So it starts as a flat part and then we bend them on a machine. But sometimes it's really easy as a press brake operator, the guy operating the bending machine, to bend a part backwards. And so I think that's like another really interesting like vision model challenge because we have like the flat patterns of the models. We know what orientation it's supposed to go into the press brake, but sometimes, it might look symmetrical, but maybe a hole on one side is like 5 millimeters off, or, maybe it's really easy to accidentally bend it the wrong way. And that's really a frustrating thing that, maybe you can catch it like in QC, but it's much better to catch these problems like upstream of that, right? So like if you can make a process change before QC, then that's like a way better solution, right? Like just never make the mistake in the first place. So I think a vision model that, like as you're bending parts, let's say I'm about to bend my first part for that example, and the vision model can see like, oh, is it in the right orientation? If it is, show a green light on the press brake, right? And if it's not, then like show a red light and maybe our screen will show like, hey, you need to flip it this orientation. So that's like a really common one that is super easy to make. Like everyone kind of makes that mistake. Another one could just be like part quality defects. Like, so think things like, oh, does the part have like more scratches than we would like on it? Is there kind of like, is the edge quality poor? That kind of thing. So there's a bunch of kind of like quality control type stuff. Trying to think what else. I mean, there's also kind of like the robotics side too. Like there's like a bunch of jobs like in this shop that are like really easy for a human to do, but are super boring. So like one example is we have a deburring machine that has a conveyor on it. And so you cut out all these parts. Let's say you cut out, I don't know, 1,000 parts, and then the the parts need to be sanded down, right? And so we have a machine where you put the parts in it, sands it down, gives it a nice finish. But that job is super boring. You're literally just standing there, you're putting parts on a conveyor. On the other side, you're taking parts off the conveyor. And so I think like we could use vision models to, do automate pick and place stuff. And we built a bunch of tech like that before we got into actually running a factory. And so that'll be another interesting area of vision models is like, how do you just like delete this whole job that is super boring and like really low skilled and like no one in the shop really likes to do it, but it ends up being kind of a bottleneck. And how do you get that to be, done with a machine instead? Yeah, there's probably like 1,000 other stuff that just like comes up that we'll see. But I feel like we kind of put off doing like the laser remnant sheet nesting thing for a while, thinking it was going to be harder than it was, but it was like pretty straightforward. It took like a week to build.
That's awesome. That's awesome. And you mentioned this, but like the way Roboflow is integrated there is you've got the overhead camera that's seeing each of the parts that are coming in, and you collected some data and then trained a model to recognize the holes and the overall sheets. That information that gets passed to the next fabrication so that you can place parts correctly. And you've written custom logic that says, therefore, here's where we should place our next parts to get the most utilization out of this sheet.
Exactly. Yeah. So like the input to Roboflow is like the image of the raw material. The output is the predictions of, where the material is, where the holes are. And then we use that output as input into our nesting software that we've built. And so that's like the, kind of like contours of the actual sheet. And then, we kind of automatically place our parts within that shape. So yeah.
I'm going to shift to Q&A for folks. We have some questions that are streaming in the chat. For folks that weren't able to join us live, make sure to check out future live sessions so you can be a part of the Q&A. Let me jump to one of the first questions here. So first one is, roughly what percentage of the total part cost is typically made up by material cost?
Yeah, it depends. It is one of the biggest factors, right? So like material costs and labor costs are probably the two biggest factors, and like how much the end part's going to be. But I would say the answer is it depends, because we have multiple kind of tiers of like speed for customers. So like a large part of like our actual like money that we get and we can actually use to like reinvest back into the business comes from like expedited orders, right? And so the cost of the part is a little bit divorced from like the costs it takes to make the part. It's more like the value you're getting is you get the part quickly, so you're willing to pay a big premium. And so for something like that, like we can have it where, maybe it's $10 of raw material and a typical shop would sell the part for $40, $50, something like that. But if we do an expedite service and we literally make it today and ship it to you tomorrow, like maybe you're willing to pay $300 or $400. And everyone is happy, like in that transaction. Like we're happy because, we get a little bit more money. We can reinvest into technology like this. The customer's happy because they really needed the part, because they have like 10 engineers kind of like waiting for this part, and like they don't really care. It's, kind of like part of their iteration process. So they don't really care that the cost of it today. But yeah, I would say often the material cost is something between 10 to 20% of the cost of the part that we end up selling to a customer if it's not an expedite order. And if it's an expedite order, it could be bigger, a smaller portion of the total cost. Also for things like weldments, the material cost is even less of a percent of the total part cost. In that case, you're also paying for a lot of like the skilled labor, right? And so we have a lot of ideas on like how to make welding faster and like be able to do more quick turn stuff in that space. And so, yeah, for welded part, maybe it's something where you buy an enclosure and you pay us $1,000. Maybe it has $150 of raw material in it, but it has, a bunch of hours of welding. So that kind of changes it as well. But yeah, there's a bunch of different factors, right? Basically, the more secondary processes that you have also that kind of like inflates the cost too. So like if you need a part bent and it needs powder coating and it needs to be welded and it needs hardware insertion, um, then it kind of changes the calculus.
Awesome. That makes sense. Um, Someone that is very eagle-eyed on vision techniques has a question and potential suggestion. Could
Oh,
you
okay,
color
great.
could you color the background of where the sheet is placed to give greater contrast between the sheet metal and
Mm.
the fabrication machine? The thought is that
I
that would give
don't.
you better detections.
Yeah, I don't think so because the slats that are on the laser bed end up getting a lot of like debris on them, right? So they get covered with like the debris of the material that you're cutting. So if you cut a lot of aluminum, then the slats quickly get covered. Probably in like a few days of cutting, like the top edges of the slats would be back to being metal colored. Um, but it seems like it's working like fairly well so far with like a very minimal amount of images. So I'm pretty confident like we keep labeling and keep adding more data that this will get even better. But even in its current, like not super accurate state, it's like already a step change improvement, like how we make parts.
That's something that I want to emphasize is that a lot of folks in an AI versus software world, it's in software, it's like deterministic. So there's this tendency that I should only deploy something when I know exactly what the result that I'm going to get is, and it's 100% certain. In AI, it's actually, if I'm starting to get value, even if it's not 100% accurate, like in your case,
Yeah.
it's a great example. We're deploying a first version and then continuing to collect examples of the various parts that are being fabricated only gets better. And so deploying a first version, even if not fully bulletproof, still adds value to the process. So I really like this example as one where that's true. We have a question from Patrick. Patrick, I can let you maybe actually join us on stage. Yeah, sweet.
Hello, I'm coming off of mute to ask my question. While I was watching this, you reminded me that there are some other situations where, with complicated tasks, people want to weave together a couple different vision models. For example, I've seen like robotic arms. One model needs to figure out where the area of interest is when they're
Yeah.
picking up something, and then
Yeah.
the next model is to classify it according to the
Yep.
SKU so that it can pick it up and put it in the right
Yeah.
bucket. And then there's a third model. So I was wondering if you could tell us, do you have any experience in these kinds of use cases, weaving together multiple models into a sort of multi-stage process like that?
Yeah, for sure. So we did a bunch of this when we were working on like the pure robotics play thing. And the general kind of thing was like, can you identify like first, can you like figure out what the user is asking for? Like, what do they actually want to kind of accomplish, right? And so it was like, first you like use an LLM to kind of like parse like, what the user has like typed out. And the form factor of what we built was basically like a robotics, like a 3D editor where you can kind of like set up your environment and you could see the robot kind of do the tasks. And then you can actually like either like drag and drop kind of building blocks for creating like a robot routine, or you can like type into an LLM and it would like compose these different kind of like sub tasks together to give you a routine. And so basically like you could do something like tell it, hey, place all the red items into box A, and you've already pre-configured like where box A is or something. And then it would, chain together like different models, right? So it would have like, maybe it would use kind of like some kind of like, maybe it would use SAM, right? To like figure out like which part is like the actual marker. And then we would pass it into kind of like a grasp detection model. And that grasp model is like a robotic specific thing for like, if you have some image of a part, like where do you actually like place the grippers? And then we would use all that information and chain them all together to accomplish a task. And so it was really fun. It was really cool to build. It doesn't work 100% of the time, but that it's been a few years. It's been like definitely like a year and a half at least since we hacked around with that kind of stuff. For the thing that we're doing right now, it's fairly straightforward. There's just kind of like one vision model in place. We're using the Roboflow 3.0 instant segmentation model. And the other part of this, like I want to emphasize too, is like I'm not like a computer vision expert like whatsoever, right? Like I feel like that was kind of the hesitation and like, hey, like how do we go out and like we build this stuff? it's going to take like some serious like engineering effort. We're going to have to kind of like level up and like, really do a bunch of stuff. But at risk of sounding like a shill, like Roboflow, like made it incredibly easy to do all the labeling, deploy the model, interact with it. And so, yeah, if you haven't messed around with some of this stuff, like I think it's like fairly approachable for kind of like the average developer to get in and start building like real useful stuff.
You had another question here on the algorithm you use to do placement. Once you have the Roboflow model tells you here's where we have available space on the sheet. Then you separately have inputs of size of parts that you want to place on that remaining remnant. The question is around what level of optimization you do in that placement of future fabrication on the available material. For example, do you place small parts in the corners, or do you try to like create a puzzle, or do you just kind of naively place everything left to right on the available area? It's almost like the traveling salesman problem of available space. And so the question is asking about what level of sophistication you've invested in for using the leftover area.
Yeah. Basically, it's super naive stuff right now, right? It's like a CS 101 type of nesting algorithm. But I think that it's a really interesting space. There's like a lot of different constraints that can be added to the problem. So like, for example, if you are going to cut and then bend a bunch of parts, it makes sense to cut all the parts out in the same direction because the material has a grain on it. And if you bend one part that's cut, perpendicular to the other, and you bend it with the exact same settings on the press brake, you might end up with parts where there's like a degree or two off. There might be some deviation. And so that makes the press brake job harder. And so I think it comes down also to like, are you optimizing like this one step? Or are you optimizing the entire flow of the factory, right? And I think it could be a trap to just like hyper optimize over kind of like one cell without thinking about the stuff downstream. So that's like one example of like another interesting constraint that can happen. And another one is what's called tip-ups. So the bed of the laser is composed of a bunch of slats parallel to each other and spaced out. And then they have spikes on them. And so you lay the material on top. And if the material is like large enough where it's not going to, where once it's cut out, like it'll sit on the different spikes, it won't fall out or tip up. But if the material is like, say it's in the space between two slats, you cut it out, it's free from the rest of the material, it can tip up, and then the laser doesn't know that it's tipped up, so it could crash into that piece. And so then another part of the nesting optimization could be, are you placing the material in a way where it's not going to tip up? Mm-hmm. And there's like there's like more and more and more of these kind of things, right? There's like, are you cutting it in a way where you're applying too much heat to like one section? And so over time, like we're going to keep adding more of these constraints in and like make the nesting software smarter with the goal of, basically keeping the laser running as much as possible, making sure the downstream processes are easy to do, preventing like things like from the laser crashing into the material. And so, yeah, right now it's super naive. It's basically like shovel the parts at the bottom left corner and then like keep shoving them in and then kind of like, kind of Tetris them or whatever. And so we haven't spent a ton of time on it. It'll be really interesting to see, oh yeah, tip outs, train a model to stop the laser. That would be great, actually. So I think Zach is saying like, you could have a vision model running. If you see a tip up, you could pause the laser like automatically. Yeah, so there's a bunch of stuff like that that's like really cool from the vision aspect, right? Like a big part of the operator job is just kind of like load the material, run the program, and then if something goes wrong, kind of like troubleshoot. Or if you could prevent something from, like if operator sees the tip up, they'll pause the machine and they'll like go grab the part out. And so, yeah, I think there's like a bunch of different interesting things.
Two other quick questions from one of the same person. So one of the questions is like, from when have you been leveraging this? And I think you mentioned like it took like a week to build, and so maybe you can give a little bit of the timeline. The second question is the accuracy as you've rolled it out.
Yeah, for sure. So We started using this about a week or two ago, and it took like a week to build. And honestly, a lot of the time spent building it was like, hey, getting the camera, hanging up the camera, calibrating the camera, that kind of stuff. The software side was fairly straightforward. As far as accuracy, I think there's like a couple ways to think about it. So like there's, okay, does the model produce an accurate outline of the remnant sheet? And so today it's not super accurate, but it's, like I said, it's useful enough for us to use. And as we collect more samples, we anticipate it's going to get much, much better. The second part is like, has it placed the line like accurately enough on the sheet? And like, does that map to the real world? And so what we did was, we hung up the camera. All cameras have, some distortion on it. And then we did the whole kind of like charcoal board camera distortion kind of flow for fixing that. So we printed out like a really large charcoal board. Yeah, I would say like right now, it's probably about on the order of, if you see a line on the sheet, that line is probably about a 1/4 inch-ish away from where the real end is. And so what we can do now is basically like in the nesting software, add just like a 1/4 inch of padding around all the edges. And so the, that will kind of like make sure the parts stay on the sheet. And then the last part is like, is it cutting parts accurately? Like that's all in G code. That's all very accurate, right? So like then we can make the parts basically to like 5/1000ths of an inch, like in overall dimensions from the design. So still able to make like really accurate parts. But yeah, I think over time we'll get it a little bit closer and closer where it's like closer to that margin. It would be great if it could be, a millimeter or two kind of accuracy. I don't know if we'll get that close, but even, like I said, even 1/4 inch is great because like now we get to use the sheets that we weren't using before. So yeah, that's awesome.
Amazing. Those are the questions that we had. I mean, kind of super appreciate the time that you've taken to walk us through everything you're building, how Vision's a part of it, and the feedback that you've had for the Roboflow team. I think something that's very inspiring about what you're building and working, it's basically, if you built a factory in the 21st century with an eye for agents to parse engineering quotes as they come in,
Yeah.
a sense of visual AI to figure out how there's automations and optimizations you can make all throughout your process, you are building the future of what facility and production should look like. And it's very inspiring for me to see that and have that take place in Texas and in America, just as much as be a small part of powering many of the optimizations and automations that you're making with Vision. So thrilled to be a tiny part of powering such an incredible operation you're building.
Yeah, no, this is really cool. And like we've talked before about this, Joseph, but like the idea of like, APIs for the real world and like just like using software to actually like interface with the real world is super powerful. Like it feels like it's still super nascent today. But yeah, it's great. And for us, it's awesome that tools like, Roboflow exists. It just makes it so much easier to build these like things that like make a material impact. And I think like, I don't know, for me as a founder, it's like a really interesting problem because it's so fun to like solve something or like know like, hey, like we spent a week on this and this is like, we're going to reap the benefits of this like for the rest of the lifetime of the company, right? It's
Yeah.
like, it's going to be faster to like, train operators. They're going to make less mistakes. We're going to use more of the material. And, as order volume and stuff grows, like the value of this software that will be deployed is going to be more and more valuable. So yeah, it's really cool.
Tremendous. Is there anything that you ask of viewers or feature requests for Roboflow? What can we do to ensure the success of RMFG?
Oh man. Yeah, if you need parts, especially if you need assemblies or welded parts, we'd love to chat. If you've ever interfaced with a contract manufacturer to bring something to market, really interested in talking to people in that domain. On the Roboflow side, I don't know, it was really easy. I think I sent some feature requests on like some keyboard shortcuts and stuff on the labeling side to make things like a slightly easier. But it was honestly like really easy. So I don't really have much to ask for on the Roboflow side.
Awesome. Do you still cut custom signs for for companies and startups? Like if someone wanted
Yeah,
their
yeah.
name out of sheet metal, will you
Yeah,
still do that?
we do.
Okay.
Yeah. We have handfuls of companies. We can send you a sign. Yeah.
Oh yeah. I mean, I was going to order one, but I was also going to say anyone in the audience, like if you want to
Yeah.
order your
Yeah, sign for your
name or your
startup.
company
Yeah.
name or your startup. I
Yeah.
remember that Kenneth and his company do that. So
Yeah, I
awesome.
don't know. That actually felt like an unforced error in some way because, like, for a while, people were like, "Oh, you guys are the sign guys," and we're like, "No, we want to make real parts." But we do a fair amount of like signs and stuff still. But I feel like it's just like stuck in people's heads. Like, okay, it's less like as we keep building and like putting more stuff out there, it's less a thing. But like a part is a part, right? Like often we don't
Yeah.
even know what the part is for. It's like, it has like the default name from their CAD program. It's like Part Studio 1, Part
Yeah.
Studio 3 or whatever. And we're like, we have no idea what this is going to be. So like we have people building, like we have a customer right now building, I think like a jet powered skateboard, I think as
Wow.
far as I can tell. We have customers building, like custom end of art tooling for robots, robotic bases, like all kinds of stuff. And yeah, we have customers like ordering signs, and yeah, we'd love to cut some signs for you guys. If you want any kind of custom sheet metal parts, like yeah, happy to do it.
The curse of doing something well. You get known for that thing. I remember very early, like we had tools for like data augmentation, and people were like, "Oh, Roboflow, the data augmentation tool." And then we added tools for like labeling. People were like, "Oh, Roboflow, the labeling tool." And now it's like we actually do a lot for deploying your models just as you are, for running them in the factory and getting the detections and passing the results. Like, oh, Roboflow, the deployment company. So I think it's a good sign
It
that
evolves,
you've done something so well with the signs that other folks it's better to be known for something than not be known at all, I suppose. So I still need to order our Roboflow sign. So maybe that'll be the follow up for future time.
Sounds
well
good. Well, great to catch
Kenneth,
up, Joseph.
yeah, great to see you. Thank you for making the time.
Yep. See y'all.